Welcome everyone to this bonus section on Python GUIs or graphical user interfaces with IPy widgets. So we're going to show you how to build simple graphical user interfaces with Jupyter. And because we're going to do this exclusively with Jupyter, that's why we consider this bonus material. There are lots of libraries out there for graphical user interfaces, each with their pros and cons. There's the built-in tkinter, which doesn't look that great, but it's built into Python. There's also solutions like PyQt, which then, if you actually want to use it as a product, there's some licensing issues you need to deal with. But there's the open source IPy widgets and widget styling structure within Jupyter, so that's why we decided to use it for this kind of bonus material section. So we're going to explore how to build out interactive elements. These are things like buttons or sliders that you can have directly in a notebook for someone else to play around with. You're going to want to keep the lecture notebooks handy because there's a lot of reference code and information there for you. So let's get started with our very first lecture in this topic, where we're going to discuss the interact functionality. Let's open up a Jupyter notebook. Okay, so here I am at a Jupyter notebook. As a very quick note, for the notebooks that go along with this lecture that are hosted at the repo, you actually won't be able to see the sliders that we create or any of the interactive elements that we're going to be creating. That's because this is just hosting the code itself. It's not actually running it. So NBViewer or GitHub won't actually be able to execute the code here. They're just showing you the code itself. So keep that in mind if you come visit to the GitHub and you're wondering why you don't see sliders here. You need to download this notebook and run it with Jupyter Notebook in order to actually see or view the widgets and interact with them. So keep that in mind. And again, this is all under bonus material, Introduction to GUIs or GUIs. So let's get started with the interact function. In order to do that, we need to say from IPyWidgets, import, interact, and you can use tab autocomplete here, interactive, and also fixed. And then we will say import IPyWidgets as widgets. So once we're done with those imports, we're going to create probably the most basic interact function. So at a most basic level, what interact does is it auto-generates a user interface control for some sort of function argument. And then it calls the function with those arguments that you can allow yourself to manipulate interactively. So to use interact, we first need to define a function that we actually want to play around with or explore. So we're going to create the most basic function possible, which is just, well, it's not the most basic function possible, but it's definitely a basic one. You take an x and we return back x. So super simple function here. And then we're going to call interact, and you pass in the function itself, and then you set some default value for the arguments of the function. In this case, there's one argument. And then when we run this, we should see a slider here. So then note how as I'm sliding, I have this x value, and this is my input x that I have highlighted here, and this is my output x. So if I scroll around or slide around, I get to see the actual results. So let's explore this concept further. Let's imagine I wanted to return the square of x. If I rerun my function and rerun interact here, now I'm returning back the square at the bottom. So I can see here as my slider goes from -7 to 25, I'm just returning the square there. So I can see here how I can vary the input and then see some corresponding output. Let's go back to that simple function where we just return x. So we saw that we get a slider when we're working with integers. Let's see what happens when we pass in booleans. So with booleans, it auto creates a checkbox, which makes sense because booleans are either true or false. So here, now we automatically created this checkbox. Mark it check for true, unmark it for false. And then if we actually pass in a string, such as hello, then I get back this auto text box. So right now, this function is just accepting x and returning x, and interact is smart enough to know what kind of feature it should show you based on the data type that's being passed. So for integers or numbers, it passes in a slider. We just saw for booleans, it passes in a checkbox, and then for strings, it passes in a little text box here. So I can type whatever I want, and you'll notice that this function is just returning x. So lots of cool functionality here. Now what we're going to do is, instead of passing in this function into interact, we can actually do all this with a decorator. So let's see how we can do that. I'm going to click exit here to kind of end this. I'll come back to a function. Let's create a new function called g. and G takes in X and Y. And then all it does, it just returns back a tuple of X and Y. Again, a very simple function. Now what we could have done is pass this function into interact again, and then provided something for X and something for Y. But we can do all of this with the decorator. And if you're unfamiliar with decorators, make sure to go back and review the decorators lecture. But there's a decorator called interact, and here we can pass in the default values that we want to start off with. So I can say something like X is equal to true, and Y is equal to a floating point, let's say 1.0. And now when I run this, I actually get back these options. So I can say true, false, notice my output here, and then I have this slider. Now let's imagine we actually wanted to keep one of these values fixed. We didn't want everything to be manipulated by the user. What we could do is pass in this parameter into the fixed function. So what we would do here is just say Y is equal to fixed 1.0, make sure my parentheses balance up, and then when you run this, you no longer have the option to pass in Y. It's been fixed at 1.0. And this also works inside the interact function. So if we rerun func here, and I say X is equal to hello, and I say fixed hello, then when I run this, I don't get the option of that text box anymore. It just fixes this parameter to always be whatever that default was. So that's how you can use the fixed function. And so now we have the interact function as well as the interact decorator. Now let's talk about widget abbreviations. Recall that when we said interact, passed in our function, and then said X is equal to, let's say, 1, we get back this value of a slider, and I can go to some minimum and to some maximum. But notice what's happening here. I can only go to a minimum of -1 and to a maximum of 3. And if I were to expand this to 10, suddenly I can go to a max of 30 and a minimum of -10. So what happens is your minimum is defined by the X and your maximum is defined by X times 3. So you may be wondering, well, how do I actually change my minimum, my maximum, and even my step size or my starting value? What you can do is instead of just saying X is equal to 10 and have it automatically create this integer slider for you, you can call widgets, int slider, and then you can pass in, if you do shift tab here and expand this, you'll actually see the arguments you can pass in. You can pass in minimum, maximum, step, and value. So let's do that as well. And remember, this is an integer slider, so our step size needs to be an integer. There's also a float slider in case we want that. But now I can say my minimum goes to -100, my maximum goes to +100. We can create a step size of 1, and then our starting value of 0. So now I have all these options with the integer slider. And if I rerun this, notice I'm starting at 0, I have a step size of 1, and I can go from -100 all the way to +100. So these are the widgets that you can specifically call if you want more options in the functionality of the widgets, instead of just the ones that are auto-created for you. Now, because sliders are so commonly used with widgets, there's actually ways to abbreviate all this functionality here. And the way you do that is by calling interact, pass in your function, and say X is equal to, and it's very similar to arrange. What you do is you have a tuple here where you have a min, max, and a step size. So I could say go from -100 to 100, step size of 1. And then when I run this, notice I get back the same thing from -100 to 100, or I can go from -10 to 10, rerun this, and here's -10 to 10, step size of 1. This is known as an abbreviation of this widget right here, because now I'm just passing in an abbreviated tuple instead of calling integer slider. This is an integer slider, and if we wanted this to be a floating point slider, all you had to do was specify one of these to be a float here. And then if we specify the rest to be floats as well, so let's say 0.1, and we rerun this, now Jupyter Widgets realizes, oh, he wants a float slider, so then we have the floating point slider here. And notice now our step size is 0.1, and we're going from -10.0 all the way to +10.0 in step sizes of 0.1. Again, using this abbreviated format. And as always, you can do this with the interact decorator as well. So if I say at interact, I could say X is equal to, and then say 0.0 to 20.0, step size of 0.5, create a function. Let's just have this function be h, and we can have some default value like 5.0, and then just return x. So then when I call it, I have the default value of 5.0. It goes down to 0.0 all the way up to 20 and step sizes of 0.5. Okay, so this is widget abbreviation again, lots of different options here. Those were the abbreviations for integers and floating point sliders. You can also have drop-down menus, and those are abbreviated as well. Remember that if I said interact, pass in my function, and I said x is equal to a string, such as hello, it just has a text box here automatically generated. So hello, how are you? And it's just returning back that string. If you pass in a list of strings as an abbreviation of a full call, it will create a drop-down menu. So we can say hello, option 2, comma, another string, option 3. And now when we run this, we get back this nice little drop-down menu. Option 2, hello, option 3. So this abbreviation of using a list with strings is a drop-down menu. And we have a little table in the notebook so you can reference this and not have to memorize what tuples stand for or what lists stand for. But when you get used to it, it's pretty straightforward. These tuples are sliders. The list with strings is going to be a drop-down menu. And there's also, when you pass in a dictionary, let me show you what happens. We'll say interact, our simple function, say x is equal to 1, 10, and then we'll say 2 goes with 20. And when you run this, you get back a drop-down menu 1, 2, but then the actual output is equal to the value here. So your drop-down menu is the key, and your output is the actual value. So notice the difference here between that list and that dictionary being passed in there. Now, in addition to this interact function, IPython, or Jupyter in general, provides another function called interactive instead of interact. And it's useful when you want to reuse the widgets that are already been produced or access the data that is bound to the user interface controls. So unlike interact, the return value of the function will not be displayed automatically, but you can display a value inside the function using IPython.display. So to show you what I mean by all this, say from IPython.display, import display, and let's create a function here. Simple function f just ticks in a and b, and then instead of just returning a plus b, we're also going to then call display on a plus b, and this will allow us to use the interactive function. So then I can set w equal to interactive, pass in f again, and we'll say a is equal to 10, b is equal to 20, and if I check what type w is, notice it's now an interactive object. So the widget is an interactive, which if you look at the documentation is a subclass of something called a VBox, which is just a container for other widgets. Now the children of interactive, if we check out the children attribute, these are actually two integer sliders here, as well as an output. So it's basically building out a larger UI for you using the interactive functionality. So then if you actually want to finally see what W actually looks like, what it was defined by this interactive function, you can call display on W. Let's make sure I spell that right. And then you get back both sliders. So you get 27, -2, and you get to see the sum. So 27 minus 2 is 25. And now you can see how we can use the interactive functionality to save something as a variable and then just display the variable later on. Okay, so that's really it for the interact and interactive functionality. Let's very briefly go over everything we just covered. The main idea here is that you're going to be able to create functions that take in some sort of input and return some sort of output. Then if you want your user to have some sort of interface to change the possible inputs and then see the outputs, you can use the interact function, or you can use the interact decorator. And then we saw how we could specify actual widgets inside of the interact call itself, and we saw how there's abbreviations for them, such as the tuple for a slider, or the list for a drop-down menu, or a dictionary for a drop-down menu that has a connection to some key value pairs. Then finally, we saw how we could use the interactive functionality in order to save this to a variable so I can later display that variable and again see the inputs and the outputs. Last thing I want to note here is when you're using the Jupyter Notebook, you may have noticed that there's this report here that the output is some sort of function. If you don't want to see that, all you have to do is have a semicolon here, and then when you run this, you will no longer see that output. And that's what's essentially happening when you call display on this W. You don't see that little output cell. Okay, we'll see you in the next lecture where we begin to discuss more capabilities of widgets. Welcome back, everyone. In this lecture, we're going to continue building off our previous understanding of interact and interactive to begin using full widgets. Let's get started by opening up a Jupyter Notebook. To begin using our widget framework, we need to say import IPyWidgets as widgets. So widgets have their own display functionality. When you say widgets, let's make sure we spell that right, dot, and then the actual type of widget you want. You notice that there's tons of options here. We're going to show you a few of them, and we'll start off with the first one that we've kind of already talked about, which is the integer slider. So if I just call this by itself, I get back an integer slider with some sort of default from 0 minimum to 100 maximum, and then I believe it starts at 0 there. Now right now we're just calling the widget directly in a cell and seeing its output below. But if I want to call it or line up a bunch of widgets to call later on, what I need to do is call display on the widget that's been defined. So what I need to do is say W is equal to this particular widget, and then from IPython.display, import display, and then I can display my widget. And so now I have this variable that I can display wherever I want, an integer slider. If you do Shift Tab here and expand it, it will tell you the various parameters, value, min, max, step, that it takes. So if we want to do multiple display calls, for example, if we want to display the same widget twice, the displayed instances in the front end will actually remain in sync with each other. So let me show you what I mean by that. If I say display W again here, and I start moving them around, these are actually in sync because they're referring to the same widget. W is just connected to a singular integer slider, so now I can see how these widgets are connected. If I want to close a widget, what I need to do is call its close method. So I can say w.close, and now this widget has been closed, and I no longer see it in any of the cells where it was being displayed. Now widgets also have properties, so all of the IPython widgets share some sort of similar naming scheme, and to read the value of a widget, you can query its value property. So what I want to do is reconnect that widget, so say W is equal to widgets.integer slider, and then display W. And while W is being displayed, that means I can play around with its current value. So if I do w.tab here, I can see that it has some variables that I can call. And one of them is the value, so I can see the current value it was at when the cell was run. Note, this is not going to be updated if I start moving it around. I would have to rerun this to then check on the current value. I can reset the value though, saying something like w.value is equal to 50, and when I rerun this, notice that it's connected to this current display, so this display suddenly goes back to 50 when you reassign that value. So in addition to value, most widgets actually share keys. So you can call w.keys, and you'll get back a list of keys here. So this is the entire synchronized list of stateful properties, and by stateful properties, I mean these are the properties that are connected to the state of the current display. That way, we can actually grab that property and reassign it, and it should affect the current widget display. So here I can see, for example, underneath my keys, I had a max value. So I could say w.max, and let's set that equal to 2000. So now when I run this, and I come back up here, if I scroll all the way back up, it's now been changed to 2000. So I can grab the list of keys and then see the stateful values here that I can play around with. A lot of these we won't really need to play around with. The main ones are like max, min, step, and then other options depending on what kind of widget you're actually playing around with. So we can then link two similar widgets. So if you ever need to display the same value two different ways, what you can do is link two different widgets together. Let me show you what I mean by that. Let's create a widget A that is float text, which means if I just display A, I get back this text box, which takes in floating point values instead of just normal text. Then I'm going to create inside the same cell widgets, and I'm going to create a float slider. And now let's display, let me close this off right here with the X. Let's display A comma B here. And when we run this, notice right now they're not linked. If I raise this up and down, I don't see a change in value here. And if I change the text box value, I don't see a reflected change here. What I can do is link them up by saying, after the display, my link is equal to widgets, and you can call it JS link for JavaScript link. And what you do here is you say, grab the name of the widget and the string key of what you actually want to connect. In our case, we want to connect the value. So what we're going to do is pass in the string value here, and then you pass in a list of what else you want to connect as a tuple, where it's a widget, and then the key you want to connect, so value. So if I run this now, and I start moving this up and down, notice how they're connected. So if I type in a number here, it's going to be reflected in the slider itself. So if we go to 100, you can see how it's changing. Or if I slide this, you'll see how it's changing. So again, you create two widgets, you display them, and then you can link. And it doesn't have to just be for two widgets, it can be for two or more. You call widgets.js link, and then you pass in tuples of the widget name, and then the key of what you actually want to link. So what we could do here is instead of linking value with value, even though it's a very common link, we could link a max together. So I could say link the value of A to be the max of B. And then when I rerun this, notice right now my value is 0, so that's the max of my slider. But if I change my value to 1000, then suddenly my slider can go up to 1000. Then if I change it back to 100, then I can only go up to 100. So this gives you an idea of how you can link the different keys of one widget to the different key of another widget. And it's just widgets.js link. If you want to unlink the widgets, it's actually quite simple. You just call myLink again, and then call the method unlink, run that, and now they're no longer linked. If I start moving this around, or if I start changing this, it doesn't actually affect this original link anymore. Okay, so let's quickly review what we just covered. We talked about widgets. We've actually already seen a lot of this in the previous lecture, but we saw how we could call display on a widget in order to see it. And then we also noticed that widgets themselves have these keys that allow us to view their stateful properties. And again, the stateful properties, that term is just to say that's a property that shows up when you view the actual widget. So it's a state property that you can then edit or change. And then you can link widgets together using this widget.js link, and then pass in the widget itself, and then what you want to link, in which case what key you want to link, such as the value, or here widget B, link the max together, and if you ever want to unlink them, you just call unlink. That's it for this lecture on widgets basics. Up next, we're going to talk about widget list. We'll see you there. Welcome back, everyone. In this lecture, we're going to have a reference of a list of all the widgets available to you. So we're just going to actually run the corresponding notebook that goes along with this lecture, because we're just going to show you every possible widget. That way later on, you can come back to this lecture or come back to the notebook and reference it when you're thinking of a particular widget. So let's go through that notebook now. All right, here I am at the widget list notebook. It's the third notebook underneath the bonus material introduction to GUIs folder. And if you want a complete list of all the GUI widgets available to you, just import IPyWidgets as widgets, and then for item, and here's the call widgets.widget.widget_types.items, and then you can print out item. If you just print out the item itself, it'll give you this large information in the tuple about the actual class it's in. So just say item indexed at 0, and then you'll get back the actual items themselves. So you can see here there's checkboxes, there's the sliders we were talking about, color pickers, date pickers, math. There's a lot of stuff here, And what we're going to do is just explore a lot of these. So first off, there's 10 numeric widgets in IPython. So these are all designed to display some sort of numeric value. There's the integer slider, and we've also shown you all the various parameters that can go with this. So the integer slider, you can name it. So notice here how it has test as a string. So that's the description, and you can edit that to change what text shows up here. And you can also see that it has an orientation. And if you have the float slider, very similar thing, except it's float. And you notice that it has some sort of precision, so the step size can be a float, unlike the integer. We can also display these vertically, so there's an orientation. You display it vertically, you get this sort of output. There's the range slider for an integer. So this allows you to actually grab a range. So notice here how there's two dots now, a start and a stop, and you can see which one you have selected, if it's filled in or not. Same thing for float, start, stop. You can have a range there, and it'll display back the range. There's integer progress. So you can see here it's kind of like a loading bar. So you could have something like this technically be updating as you are running some sort of program. So you can see here as a description, loading. It doesn't have to be loading, it can be whatever you want. There's also a bar style, so you can replace it with these strings right here if to see it in a different color. So if you say success, it will change it to green. If you say warning, it will change it to orange. And these colors are just from Bootstrap. So if you're not familiar with Bootstrap, it's this very popular front end styling that you can use. And a lot of these keywords come from that Bootstrap library. So that's integer progress. Same thing as float progress. You can see here it's loading. And then there's bounded integer text. So the numerical text boxes that impose some limit on the data. So you can see here we have text, and then we can say 8, hit enter, and then it would end up connecting with whatever widget you had, or whatever function the widget was connected to. And then we have just integer text and floating text. Then there's also Boolean widgets. There's basically 3 widgets that are designed to display a Boolean value. There's the toggle button. So click them on and off. You can see here it's shaded. Again, you can use these sort of Bootstrap codes to change the actual styling as far as color is concerned. So now we have green, click on and off. We also have the checkbox, which we've seen before, check on and off. And then we have valid, which provides a read-only indicator. So you can't really interact with this. It'll just say whether or not it's valid. So this is to show something. If it's false, it'll have an X there. And if we change this to true and run this, you'll see it has a check mark. Then we have selection widgets. So several widgets here allow you to select from a list. You can see we have options as a parameter that we can later link up to our functions. So you have the drop down 1, 2, 3. You can also use a dictionary here instead of a list. So 1, 2, 3, and the output will correspond to the value going with that key. We have radio buttons that we can choose from. So pizza topping, pepperoni, pineapple, anchovies. We have select. So this is again a similar drop down. We have selection slider. So you can see here as you go, you get the different options. So not super popular, but it's there for you. Then the next one we have is toggle buttons. So if you run that, you get to see these different buttons you can toggle, slow, regular, fast. You see here you have the options that you can toggle on and off. You can have multiple with select multiple. So here I can say use shift to select multiple, or you can also do control or command depending on your operating system. We have string widgets. We have the normal text box, which allows you to type stuff out there. We also have text area. So this one allows you to expand it to a larger area. We have label widgets, which is useful if you need to build some sort of custom description next to a controller. So here we can see we're actually using what's known as LaTeX. So I can write E equals MC squared using LaTeX. If you're familiar with that, you can have that option. If you're not familiar with it, it's not really a big deal. It just basically allows you to really customize the text here. But as we just saw, a lot of those widgets already have a description parameter for that. Then there's HTML. This allows you to basically just put straight HTML here. So I can see some HTML hello world. HTML math. So if you're familiar with HTML math, you can put that in as well. Basically just allowing you to display HTML in case you prefer writing your own raw HTML here. There's images. In this case, we actually don't have this image, but you would be able to connect it to an image and it would see it. Right now I get file not found because I don't have a PNG file there, but you would just connect it and it would display that image for you. I'm going to comment this out for now. Then we have the button, which is just, again, click me, click off. Very similar to the button we saw earlier. Okay, Those are a list of all the widgets. There's even more widgets described in the Widget List Advanced Notebook, so just use that one as a reference for yourself. We'll see you at the next lecture, where we're going to be discussing widget events. Welcome back, everyone. In this lecture, we're going to learn about the various ways to style widgets, and we'll discuss how to use the style versus the layout functionality of the IPyWidgets system. Let's open up a Jupyter Notebook and get started. First off, before we continue, I want to mention that there's actually quite a bit of information in this widget styling notebook, as well as discussion on style versus layout. A lot of what we're going to talk about here assumes some knowledge of HTML or CSS as far as the terms are concerned. So if you're already familiar with HTML and CSS, a lot of these terms such as border, margin, padding, top, left, bottom, flex box, those are going to sound familiar to you. If you're totally new to that, just keep in mind that this layout and styling is based on HTML and CSS, so you may want to learn about those first through just some simple web tutorials or another course of mine on Django web development, and then come back to understand layout here fully. We are going to show you some examples that should make sense even if you don't know HTML and CSS that well. We're going to get started by importing IPyWidgets as widgets, and then from ipython.display import display. Then I will create my widget slider that we've seen before. So an integer slider, and then let's display that integer slider. So right now, this is the default integer slider display. But let's imagine that I actually wanted to change the size of this slider. I wanted to change the way it looks. What I can do is grab W and then grab layout off of this. And if you hit tab here, you'll notice that you have a bunch of traits based off of CSS that you can adjust. So for example, you can adjust the margin to go with the string auto, and calling layout again, you could adjust the height of this slider to be defined by a certain number of pixels, like 75 pixels. And now when you run this, you'll notice that we've been able to shift this around with the margin and the height. So the layout here basically allows you to center the slider and then increase the height. So the slider changes positions on the page immediately, and layout settings can be passed from one widget to another widget of the same type. So I'm going to say x is equal to widgets.integer slider, and let's give this a value of 15, and I'll give it a description too, saying something like new slider, and then I will display x. So here's my new slider. Looks like it has the default styling, but if I wanted to change the layout to match W's layout, all I would need to do is say x.layout is equal to w.layout. And then we have centered our new slider. So before we investigate the actual style attribute, it should be noted that many widgets offer a list of predefined styles that can be passed in as arguments or parameters during their creation. And these are based on bootstrap terms, such as primary, success, info, warning, and danger. What I'm going to do here is, since we've already imported widgets, I will call widgets.button. Oops, let's make sure I spell widgets right. Widgets.button. And then I will pass in a description here. We'll say ordinary button. And then we can say the button style is equal to an empty string. So if I just do that and run that, I have this ordinary button. And we've actually seen this one before. What I could do though is give it a style based on a bootstrap code. And these codes are linked to in the notebook. So danger is kind of this danger red, but there's other things like warning is an orange, or you have info, which is another color, this kind of teal color, etc. And you can check out the various labels over here, primary, success, info. So now let's talk about the style attribute. So those are the built-in ones that are based off of Bootstrap. So while the layout attribute really only exposes layout-related CSS properties for top-level elements, the style attribute is used to expose non-layout related styling attributes. So those are things like custom colors. So I'm going to make a couple new cells here. So I will say B1 is equal to widgets.button, and I will say description and we can say something like custom color. And then I will grab B1, and instead of calling layout off of this, I will call style, and then call button color. And then say light green. And there's a bunch of string codes you can use here. And if I just call B1, now I see this custom color. And if you're interested in the list of all the style attributes available for any particular widget, so certain widgets will have button colors, such as buttons. Other widgets, such as sliders, aren't going to have button colors. But if we check out B1 style keys, we get to see a keys of everything we can edit. So not a whole lot here. We can edit the font weight, the button color, and that's really all there is for buttons. Now, what we could do as well is if we had a new button, such as B2 is equal to widgets button, I could set the style of B2 to be completely equal to the style of B1. Notice here I'm not actually calling style button color, but I'm just saying the entire style of B2 should match the entire style of B1. So then when I call B2, I get back light green here. So it doesn't actually say anything because I didn't pass in a description. So let's say description is equal to new, and then when I run this, I get to see the new there. So finally, we'll create some other, let's say, slider here. So I'll say widgets, integer slider. Let's give it a description to be something like my handle. And if I check what S1 looks like, it's just this normal slider. But let's go ahead and check out its style. We'll say S1 style. And if you call S1 here style.tab, you should see a bunch of options, and you can then call keys to see a list of everything. So for example, we can change the handle color. So let's grab that, say handle color, and set that equal to, let's say blue. Run that, and now I can see that little handle is now colored blue. And pretty much any major string is going to be accepted. I should say any common string. So you can see black is accepted. We could go with light blue. We could go with light blue, and that would be accepted as well. And as a quick note, if you come back down here to the notebook all the way down, we have some traits here that are common for widgets, such as button color and font weight. Those are common for buttons. Description width, handle color, those are for all the sliders. And then for the progress bars, you may want to affect the bar color or description width. There's lots of other ones that really only have description width as an adjustable trait. Okay, so you now should have an understanding of how to style widgets. Keep in mind, you don't have that much access to a lot of the styling, and that's because when you're working with Jupyter, Jupyter has to be able to only color the button here or the handle here and not affect everything else that's showing in your browser. So it's quite a challenge for the people who are developing IPy widgets to give you access to this sort of styling without screwing up everything that was being rendered in your browser. All right, coming up next, what we're going to talk about is how to create a custom widget. So we're going to explore just a huge custom example to see what do all of these widgets and functionality look like in practice. We'll see you there. Welcome back, everyone. In this lecture, we're going to show you a custom widget example, and we're actually just going to be running the notebook directly for this example. So you can go ahead and download the notebook and then run through it. For this notebook, you will need to install a few extra libraries, and those are NumPy, Matplotlib, and SciPy, and we'll show you those in just a second in the notebook. But let's open up the notebook and explore this example. Okay, here we are at the custom widget. This is basically going to be an advanced example of what's possible in the custom widget to try to give you some ideas of how you would be able to connect these widgets to external libraries. And in order to explore those external libraries, we're going to need to work with NumPy, Matplotlib, and SciPy, and you can install all of those using conda install and then these names, NumPy, Matplotlib, or SciPy, or pip install NumPy, pip install Matplotlib, or pip install SciPy at your command line. And if you're really interested in this sort of thing, of the more advanced aspects of Python, basically you've already finished the course by now if you're viewing this lecture. You can check out the class Python for Data Science and Machine Learning Bootcamp if you're interested in visualization and differential equations, machine learning, data science, analyzing data with Python, and that sort of thing. Here we're just going to show you one final advanced example of how you would be able to use widgets with some of these more advanced libraries. And to do that, we're going to be exploring the Lorentz system of differential equations. Basically, this is just a system of equations that are connected based on the behavior of 3 different parameters, and we're going to connect those to widgets to actually modify those parameters and see how that changes the visualization in real time. So we have a couple of lines here. Matplotlib inline, that allows us to actually view this visualization in the notebook setting. Then we have our IPy widgets and IPython display. Here we have interact and interactive, which we've already talked about. We have display and HTML, which we've also already discussed, and then clear output, which we discussed during Milestone 1 project. And then we have some tools here from those external libraries, and this is really just for visualization purposes. We have NumPy as NP, we downloaded and installed SciPy, and then we have Matplotlib, and Matplotlib is basically a plotting library for Python, which will allow us to plot some of this out. So then we're going to run this. And here is what we're going to do, and you can basically take this idea and apply it to any sort of function that's returning anything. What we have here is a function called solve_Lorenz that takes in various parameters that relate to the Lorenz equations, and then it creates a figure. It's going to set the limits of that figure. It has another function here that is actually going to compute the time derivative of the Lorenz system using some math. Then we choose some random starting points. We actually solve the equation that we saw up above, or that set of equations. We choose some different colors, and then we end up just plotting everything per line. I definitely wouldn't expect you to understand any of this because this is all NumPy and Matplotlib. This is more just to show you what is possible with Python. And if you're really interested in this, you can check out that other course that's linked in the notebook. So let's run that cell, and it's going to return t and x of t. And then we're going to call the function solve. So once it's solved, it looks like this. Notice here it's taking in parameters, angle and n, but if we wanted to see how those different parameters actually affected some sort of function, all we would need to do is call interactive, pass in that function itself, and then pass in our options. Here, remember we're using tuples as sliders, so those are the widget abbreviations. Then we're going to display w, and when we run this, we get to see all these sliders here, and we actually see how they affect the equation itself. So for instance, we can change the angle, and that will make it look like it's rotating because we're changing the angle that we're plotting at. Or we can change the number of lines using n just 2 or n all the way up to 43, and we can explore that again with the angle or with the max time, see how that affects things. Change beta, change sigma, you can change rho. There's lots of different parameters here. The main idea being is you just have a function that's returning something, and then you pass in whatever parameters that you want to play around with. And this is a really advanced example of that, but we've already worked with tons of functions that return something and that take in parameters from the user. And if you ever wanted a slider parameter or those text checkboxes, text entering, etc., all those other widgets that we discussed, you would just pass them in here, and then they would be connected to whatever function you passed in. And this is kind of an advanced example of that. Now the object returned by interactive is actually a widget object, so then you can grab the result off of that and grab the arguments. So we see here, this is the arguments right now, and then we would be able to explore those further. So you'd be able to plot out histograms of wherever you actually were in that particular time period. And then if you edited some of the more advanced parameters, sigma, change this around, n, and then you rerun these again, notice now you have the different angles that you had on. Then you could just keep going with this and make new histograms to plot them out. All right, that's it for this lecture and really this section of the course. I hope this helped you realize what is actually possible using GUIs and IPy widgets. The main idea being that once you have a function that's going to return something, you can easily give user interaction by just setting those parameters and then connecting them to some sort of widget. In this case, they're all connected to sliders, but we've already explored the many other widgets available, such as buttons, checkboxes, text boxes, expandable text boxes, straight HTML, and then we also saw how we could style and lay out our widgets. Okay, I hope you have fun exploring your own use cases for graphical user interfaces in the Jupyter Notebook system.